This lesson is on the domain of radical functions. So a radical function, of course, means that the function will contain a radical, and that is an equation or a function. It's not just an expression, which is what we've been dealing with up to this point. When we're finding the domain, it's important to understand if we can have positive or negative values, etc., just as we did with rational functions, where we knew the denominator could not be equal to 0. So to find the domain of a radical function, I need to know, can the value inside be 0 or not? Well, in this case, it can be 0. It cannot be a negative because I know I can't take the square root of a negative number. So the domain, I would have to say that t minus 4 has to be greater than or equal to 0. This value has to be greater than or equal to 0. So if I add 4 to each side, I find that t is greater than or equal to 4. So if I put a 3 in here, 3 minus 4 gives me a -1. Now it's not okay anymore. So the domain of this radical function would be all of the values greater than 4 written in interval notation. That would be including 4, so that's the closed bracket, all the way up to infinity, which is the open bracket. So we never can contain infinity. Now this one's a little bit different because this is a third root, and we all know that we can take the cubed root of a negative value, or we can take the cubed root of a positive value. So when I have an odd root like this, I can have any values from negative infinity to positive infinity. So any value that I put in there is going to work just fine because it's an odd root. So it's really those even indexes that you have to worry about. Here are a couple more for us to try. Again, I don't really care in this case about that 3. What I care about is that this is an even index, and I can't let 3 minus 4x has to be greater than or equal to 0. Greater than or equal to 0. So now I'm going to subtract that 3 from each side. That gives me negative 4x is greater than or equal to negative 3. I'm dividing by a negative 4. And when I divide by a negative, it's flipping that inequality around. And negative divided by negative makes it positive. So I know that x has to be less than or equal to 3/4 because obviously we're multiplying it by a negative. So that would be in inequality notation. In interval notation, that would be from negative infinity all the way up to 3/4. And it's okay to have a 0 inside the radical, so I'm going to include the 3/4. For my next, again, if there's no index, it's a 2. So t plus 5 has to be greater than or equal to 0. By subtracting 5, I get t is greater than or equal to -5. In interval notation, that would be -5 up to infinity. Notice the -5 has a closed bracket because it includes -5. Here are 2 for you to try, so try them both, then press play to see how you did. For my first, I've got an odd index. That makes it fairly straightforward. Negative infinity to positive infinity, and that's it. For my second, I know that 4 minus 2a has to be greater than or equal to 0. So now I have to do the algebra to isolate the a. And remember, when I divide by this negative value, it's going to flip the inequality, so a is less than or equal to positive 2. Again, in interval notation, that would be negative infinity all the way up to 2.